morning and warm welcome to everyone joining us today. Thank you for being here for our live session, How to Boost Your Lighthouse Score with Spartacus in just 2 weeks, led by Kacper Knapik. My name is Magdalena and I'm Digital Marketing Manager at Cloudlight, and I will be your host and moderator in today's webinar. But before we dive in, just a quick housekeeping notes. Today's session will be recorded. So if you would like to revisit the content or share it with your colleagues, we've got you covered. Also, feel free to drop your questions in the chat at any time during the webinar. We will have a dedicated Q&A session at the end where we'll answer all of the questions. And if you will find today's topic interesting, we will make sure to follow up all of the relevant materials after the session. Now let's talk about what we have planned for you today. I'm very excited to introduce you today's speaker, Kacper Knapik, who is Spartacus Co-Creator and Team Lead. His another nickname is also Spartacus Dad. Kacper has been involved in Spartacus since day one, and today he will be sharing some deep insights on how to improve performance using edge caching and by running Spartacus on the edge. And here's a quick look at today's agenda. First, Kacper will say a few words about what exactly Spartacus is. Then he will walk us through some of the performance challenges in Spartacus. Next, he will introduce edge caching configuration. Later, he will take a closer look at Spartacus on edge, followed by a quick reminder on why it's important to fix your Spartacus first. And finally, we will wrap up with a short Q&A session. But before we get started, just a brief word about Cloudlight, your host for today's webinar. Cloudlight is a trusted partner in building business-critical software and innovative digital solutions. We are located in Germany, Austria, Poland, and Romania with over 20 years of experience. We delivered more than 2,000 successful projects under their belt, and we are proud to support clients globally on their digital journey. And that's all from my side. Let's get started with our main topic. Kacper, the stage is yours.
Thank you. So to begin with, let's talk about what is Spartacus exactly. As Magda has mentioned, I've been a part of Spartacus team from very early days, and Spartacus is a front end for SAP Commerce Cloud. It is an open source JavaScript storefront, and there is a small star next to it. It is complicated because with, I don't remember which version, but with version probably 5, it was moved from GitHub to SAP internal systems, even though it is still available on GitHub, but getting the libraries is not as easy these days. It was built with Angular, and right now the latest version I've worked with was Angular 17, and there was a release not so long ago supporting Angular 19. Spartacus was designed to be headless, and there is another star next to it, and API first. So it is a bit complicated because ultimately Spartacus works with SAP Commerce Cloud, and you can use it with other, let's say, backends, but it's not as straightforward as we would like it to be. And the last point is CMS-driven approach, and this is extremely important because when I'm hosting Spartacus trainings, I always repeat that CMS-driven, 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 because everything shown on your website, on your in your store, is dictated by whatever comes from the backend, and this is this gives the content editor teams to have a lot of power when it comes to what is shown, new components being added, etc., etc. Let's go to the next slide. extendable, upgradable, progressive, a lot of different buzzwords. When we started with Spartacus, it was, when it comes to extendable part, it was built with extendability in mind. And this is true because for Spartacus implementations, it is fairly simple to use the default behaviors from core Spartacus, extend those features or functionalities and use it in your store with some tweaks, maybe some styling changes, but ultimately it is fairly easy to extend it. Developer friendly. If you ever worked with Spartacus, you will see that the core team really took time to make sure that using Spartacus is fairly simple in the way that all of the naming conventions, backwards compatibility, it's really a really nice thing to work with. Also automated installation, upgrading, and the modern web practices. So Spartacus has everything baked in, and you can install different modules like SSR, for example, server-side rendering. Spartacus is a library, but I would say for a bigger players, for enterprise e-commerce, and it works very well with large product catalogs we've had, and the products I've worked with were extremely big companies, and Spartacus handled it perfectly. And another thing is accessibility. In Europe, well, the European Accessibility Act is coming to be online soon, so it's also important. Currently, the WCAG 2.2 is being implemented also by our team. And the last thing is with another star, that Spartacus was optimized, or like is optimized for performance and SEO. And this is true, but the star says until some point, because without some tweaks, you can get so far with the performance score. There is this magic kind of point where you cannot really cross it without extra steps, but we'll talk about that, how to improve it in a bit. So typical performance challenges for Spartacus. Firstly, I would say that the whole Commerce Cloud ecosystem is extremely huge. So SAP has a lot of different functionalities, libraries, extensions, and Spartacus basically supports a lot of them. So having that in mind, it's a big ecosystem, and not always everything is as fast as we would like it to be. Then implementation code quality. This is something I've seen a lot. So I'm hosting Spartacus trainings, and I really am focusing on explaining that you have to take care of the really low-level standards of your code, and to make sure that you know what you're doing. And I've seen implementations from different clients, and when I looked into the code, I've seen already, or like fairly quickly, I've seen some things that could be improved. So lazy loading, prefetching, unused code being bundled, etc., etc. These things happen a lot for implementations, and I don't really blame the developers that implement Spartacus, because Well, usually when you are an Angular developer and you use Spartacus as a third-party library in your store, you don't necessarily need to understand everything about this library. So this is quite natural, but it happens. Another thing, a big performance killer is CMS content. As I said before, Spartacus is by design CMS driven. So everything that is added to the CMS, to SAP's Smart Edit, for example, everything is being rendered. So the images are the biggest problem. There are ways to improve it, and edge caching can help with this. But yeah, in general, CMS content, really big performance challenge. And lastly, things surrounding the servers themselves. So performance and location, and that's something that edge caching and edge in general can help you with a lot. There are probably more challenges, but these were the ones that happen a lot, and in my experience are most common. We will talk a bit about the edge caching in general, or like edge or edge caching. It might have different names. Just for anyone who is maybe a bit more technical, the graphs I prepared, we could argue that they could look differently, but I decided to go with like kind of an easy to understand way with the graphs. And also just to I wanted to mention that I'm not going to, when I talk about edge and edge caching, I'm not really going to focus on any specific product or like any specific company or whatever. I'm going to talk about edge in general. So typical flow, we have a user. The user is well, kind of talking to the front end, and then the front end talks to the backend. And you can see that there is a origin under the backend. I'm going to be talking about, when I talk about origin, I mean the backend server, or like the server in general. And so in this case, if we have the backend or the server really far away from you, it will cause the website to be slower, of course, because the loading times will be longer or higher. And it influences directly or indirectly the performance, and then SEO and everything surrounding that. Then we have issues with things like scalability, and if we have any traffic spikes, if we have a sale or maybe some like holiday sales, we can feel that on our front end that actually the backend slows down. We can be attacked with some bots or DDoS attacks, and then when our origin server is has some type of outage, then the front end feels it because the responses are not coming. So that would be the typical flow. Again, we could argue that maybe this graph could look differently, or maybe there is a SSR also available, so server-side rendering, and then with SSR this graph could look differently. But for the purpose of this webinar, I decided to go with that, just to explain maybe more the difference between the flow with edge and without edge. So that's just a bit simpler for me to explain it this way. And now, if we look at where the edge really is in this first graph, we can see that kind of on the left side, between the user and the front end, we have the edge layer. So what happens is that the user now, instead of talking to the front end and the server, it talks firstly to the edge. So edge is like the kind of a middleman getting all of the requests. And if edge doesn't have whatever is being requested, then it goes to the origin, so to the server. And so with this approach, the timings are way lower. So everything is faster, basically. The responses, they come faster to the user because the edge is located closer than the server, potentially, because edge is spread on different data centers. We can think about like a CDN, where we have a lot of different data centers across the globe. And basically edge is giving you the closest one and returning or like responding with the data from the closest data center instead of the real origin, the server of the company that you are visiting. And yes, this comparing to the first graph, when things are faster because the user gets the data faster from the edge, all of the metrics, performance, SEO, all of these things are improved. And now, since we talk to the edge and some of the things or like some of the data is on the edge and not really on, or like we get this data from the edge and we don't talk to origin directly, but we get those things from the edge. So this means that origin has less requests. So this translates into the infrastructure costs, which are lower, and the traffic is lower. And yeah, so this basically translates into infrastructure cost, which is amazing because then your server has less traffic. And apart from that, with this flow where we talk to the edge and edge is giving us the data, we can survive situations where the origin is down because, for example, of maybe some DDoS attack, or maybe something happened to the origin and then it's not responding, or there are some issues like technical issues. Then the edge can return the data and everyone is happy. Yes, let's go to a bit more specific graph now, like specifically with Spartacus, because the previous one was more of a generic one. And here, maybe the graph looks a bit differently, but edge layer contains the cache. And so cache is this extremely useful area that will hold the data, and the edge layer will return this data to the user from the closer location than the origin server. And so the flow is that, of course, edge layer is not going to contain every single page, every single request, every single piece of data. We have to kind of trigger that fetching. So the first user visiting a specific, or like maybe not visiting, but requesting a specific resource is going to trigger the whole machine so that the origin is returning the data. But in the meantime, the data is being saved in the cache on the edge layer. And the second request and every other will get the data from the cache directly. The origin is not going to be involved anymore. We have some edge cases here, of course, that we can set up different things like TTL, for example, which is time to leave for the cache items. And so some items we would like to cache for a bit longer, and some of them, like static files, JavaScript, CSS, and some files or maybe data types should be cached for a smaller time, like maybe a homepage. Maybe it shouldn't be cached for 1 year because it will change, etc., etc. So there are many configuration options. We did some projects where we created these configurations, and we really sat down with the client and we really talked about how often the specific resource is changing, and we kind of tailored the configurations for specific resources. And of course, the personalized data is not cached. So like my account and specifically for Spartacus, my account, cart, checkout, these are kind of personalized resources. These are not cached, but everything else pretty much is cached for with different TTLs, the time to live. Yes. And now if actually I should probably change that a bit because you cannot see it. I'll do that. So when it comes to the benefits of using the edge, so I brought back the generic graph. So because of the edge and how things and everything is faster, we are enhancing directly and indirectly the user experience. And I placed it, so the order of this list is doesn't matter really, but the user experience for me is extremely important. And so what we do is we are including slower devices. We are improving the mobile device experience for the users, because if things are faster, files are smaller, everything you can imagine in regards to how the application works, everything is faster. So even if you have really old device and slow internet connection, you are still getting a similar experience. Maybe that's a stretch because you probably will never have an equal experience, but maybe similar experience to desktop experience, for example. Then we have higher satisfaction in general, kind of connected to the user experience, but it translates into potential higher sales, because then if your page, if your PDP, so product details page, if it loads for 5 seconds, the user can just leave the website because, well, they don't want to wait. And maybe it's 20 seconds. I've seen Spartacus implementations where PDP would load for such a long time. Then something I've mentioned already, which is the data centers being located across the globe. We don't rely on the origin location. We rely on the data centers. So of course, the first request is still going to connect to the origin, but ultimately, majority of the requests and the traffic is going to be way faster, and it doesn't matter where you are, which is a huge bonus as well. Next, we have SEO. Of course, if things are faster, SEO scores go higher, and this translates into indexing. For example, Google really prioritizes websites with higher performance scores. So, well, again, it is related to sales and being visible in search engines. And lastly, probably equally important as the user experience, but ultimately this is the ultimate goal, and that's why we have this webinar. Performance score goes up, and everything else is basically a byproduct. So the SEO, user experience, all of that, but the goal is the performance. And we did have different at Cloudflight, we did a few projects already, which are related to performance and Edge, and connecting Spartacus with Edge and everything. And we did see major improvements across different performance measuring tools, Lighthouse, GTmetrix. Well, I've seen others, but I don't remember the names. And yeah, so that's the ultimate goal. And for the origin side, the backend, the server, we are decreasing the traffic. So something I've mentioned that when we talk as a user, when we talk to the edge, and the edge is giving us the responses from the cache instead of talking directly to the origin, this means that we are decreasing the traffic here on the graph to the right side, because the data is on the edge layer, it's cached, so it will just simply be returned to the user. And then looking at the infrastructure, the traffic, and the transfers of data, we are cutting it quite a lot, because if we have 1,000 users visiting and only the first one is triggering the caching mechanism, then 999 with correct configurations and whatnot will be talking to the edge and not to the origin. So the number was just completely fake. But just to show you an example that we are cutting a lot of traffic to the origin, which is extremely huge thing. Then traffic spikes, scaling, these are usual problems. And since we don't rely on the origin so much, we don't have to worry about it. So if we have high traffic, our server, the origin can be overwhelmed, because suddenly we have 5 times more traffic than usual, and the server is basically not keeping up. But with the edge, we don't have to worry about that. And similarly to scaling, we really don't have to worry about performance of our origin so much. And we really take the data from the edge. So another huge benefit. Bot traffic, DDoS attacks, and many other malicious traffic, this is also blocked by the edge, and the origin is not well attacked so much. And the last point is something I could discuss for a long time, for many hours, that we specifically decide when we want to talk to the origin. So before, with the standard kind of flow that I showed you at the beginning, everything goes to the origin. But with the edge, we can decide with our custom rules, with our setup in general, with our resource, like we decide which resources are cached for how long, etc., etc. All of these things, they kind of make us decide when we want to talk to the origin. If we have a resource that is changing a lot, this mean that we can talk to the origin more often than a JavaScript file that can be cached for 1 year. So that's extremely nice opportunity that we can decide when to talk to the origin. And so this is, as a co-creator of Spartacus, this is something I cannot stress enough. It doesn't matter how how well you set up your edge, how many more fancy features you'll come up with, it doesn't really matter if your Spartacus is not performing well. And I've seen situations where even though Cloudflight would handle a lot of edge configurations, and we came up with different approaches and solutions, ultimately we didn't see the scores as high as we wanted to be, because we found some issues with Spartacus. And so when you work with Spartacus, it is really important and extremely important, I would even say, that you ensure your Spartacus uses every single best practice there is. I mean, of course, that's not possible, but I encourage you to really think about it and put effort into it and save some budget for it, because you can implement your Spartacus and it can be mediocre in terms of performance and implementation, and that's fine. It will work, you will sell, but only with the best practices, only then you can really leverage more modern solutions like the Edge, and that will give you even more sales, more user satisfaction, and everything. So the performance solutions are lazy loading, code splitting. These help with the, for example, Lighthouse metrics. So first contentful paint, time to first byte, etc., etc. And these solutions, they really, really should be in place. It should be used, and you should know what you're doing. Because you could use lazy loading for every single component in your application, but this also can bring you bring your performance down because of reasons. And so understand what you're doing and use the performance enhancing solutions. And finally, we have the files that load when the page loads, and this is quite a common occurrence that the files, the critical files, or the initial files like main.js, style CSS, these are huge, and we place a lot of things inside, and we should really take care of that and understand what should be inside and what we can maybe extract from it and place it elsewhere. Next, we have, well, what Cloudflight is doing now. We have 3 different packages, 3 different options for Spartacus improvements. We can do up to 15% performance boost within 2 weeks, and this is quite basic configuration, but still tailored to the needs of the client. Then we have a bit more complex, which takes around between 4 and 6 weeks. It's definitely more in-depth configuration. And lastly, we have hyperspeed, which is around 3 months, and this is, in terms of performance, this is actually going into the code and changing the code base. And so all of these can help with the performance. And since Cloudflight is the Spartacus Co-Creator, we still have, after 5 years or 6 years, we still have the core team working on Spartacus. And we do have a large implementation team for Spartacus. Basically, we know what we're doing. And here we have a table with the average speed gains So with the hyperspeed, we have up to 75%. With turbocharged, we have 50, and fast track, the first one, up to 15%. And this is lastly just to show you and maybe show you a type of a visual proof of maybe that this is not proof per se, but on the left side, the 37 is a score which we had before the edge configuration. So we can see, for example, the first contentful paint being more than 5 seconds, largest contentful paint being more than 7 seconds. So that's quite a lot. And usually largest contentful paint is the banner images on the homepage. Maybe a bit different on other pages. On PDP, that would be probably the product image. But yeah, it's more of a page specific, but let's focus on homepage. So then we have the banner. We have total blocking time, which you can see didn't change much across before and after. And when we did our configurations, and it took us around a few weeks, so maybe 3 weeks, maybe 4 weeks. I don't remember exactly, but ultimately, what I want you guys to see is the difference between before and after. So 5.3 first contentful paint, we ended up on 1.7. It's green. It could be further improved, of course, but that would include some changes to the code. Largest contentful paint from 7.5 went to 2.4, which again can be further improved. The CLS cumulative layout shift didn't, well, it did change, but to fix it, it relies on the changes in Spartacus. Speed index at the bottom is basically this type of metric, which is, I would say, a summary of everything else. So it did change. But the total blocking time, this can be also changed by a correct edge configuration. But the most influence on this specific metric lies within Spartacus. It can be changed and it can be improved by the edge, but for me personally, it's easier to play around with Spartacus code to improve it than forcing it through the edge. But yeah, you can see we went from 37 to 74 within 2 or 3 weeks, which is great, which is really I would say incredible, because we couldn't make a higher score than 40 in this case. We never went up higher than that. So yeah, thank you very much. So Magda, I'm giving you the mic.
Thank you so much, Kacper, for your insights. That was a fantastic deep dive into the topic. Now we are moving on the Q&A session. We received a great question in the chat already, but we would love to hear more. If there's anything on your mind, feel free to drop your questions now. So the first question is, which Lighthouse metrics are the most important to fix to improve the overall performance score?
Okay, so looking at, maybe we can look at this slide. So edge in general helps you greatly with contentful paint. So first one and the largest one, with time to first byte. So basically how fast the server responds. And these are quite easily fixed with the edge. And when it comes to most important, according to the Lighthouse's calculator, so you can see here, C calculator, you can open that when you run your Lighthouse test. You can play around with the sliders, and you can see which one in your specific case is the most important. When it comes to the weight of these metrics, total blocking time is the heaviest, probably. So yeah, it can be easily fixed with decreasing the size of your main.js by lazy loading or code splitting, for example. Decreasing the size of your style CSS and making sure that you don't throw everything into this file. So I would say total blocking time the most important, and then everything else where CLS, the cumulative layout shift, might be the least important for the overall score.
Okay.
Yes, we
Thanks.
can go to the next one.
So next question. It seems that edge caching would not be suitable with features like live chats, which use web sockets. Is that correct?
Okay, so we really, with edge caching, what we do is we are caching specific resources. So JavaScript files, CSS files, blah, 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 but also the HTMLs. So when you open the page, you get the HTML, and this is cached, and this comes to you extremely fast. But then there is the hydration part, because you don't get the interactive page website already. There is the hydration part where everything needs to start to be interactive. So features like live chat will not be cached, because ultimately this will be a third-party library. I'm just guessing. Maybe that's your custom own implementation, but still, it will be dynamic content. And edge caching, we have by default, edge caching is not caching the dynamic content, but you can also, if it wasn't done automatically, you can also say, okay, let's not cache that because it doesn't work. We did have these situations where we cached something that wasn't supposed to be cached, but this is as simple as just changing the rules, changing the configuration just slightly, maybe including that specific resource, and that's it. It starts working again. But live chat shouldn't be cached. That's true.
Okay, next question. Is it edge caching handling dynamic CMS component data?
Okay, so for my previous performance project, the CMS data, we kind of we did cache it, but we cached it for as not so long. I don't remember the exact number now, but it wasn't cached for long. It was cached. The entire API would be cached, only to offload the origin, but not for too long, so the content is not stale. And when it comes to dynamic CMS data, this is something I've mentioned on one of the slides, that personalized data will not be cached either out of the box by the edge solution that you use, or if it doesn't happen automatically, you can create your rules, your configurations, where you say, okay, so anything specific to the user, for example, let's not cache that. So that's possible. That's something similar we did. So from the Hybris or Commerce Cloud or whatever you want to name it, the backend, we skipped some of the resources regarding the dynamic and maybe user-specific data. So in general, to answer your question, it depends on how you want to handle that. And you have a lot of different options how to do that, because yeah, you can skip them. Maybe it's done automatically. Maybe you have to write a configuration. Yeah.
Okay, another question. How does edge caching integrate with SSR in Spartacus?
So SSR, maybe I'll go to one of the slides, because I did mention SSR in one of them. So this can be a good example. So we have the backend, and the backend is rendering the content. Then it's sending, when there is a request, it's sending to the front end. So when we have the first request, it doesn't matter if we are using SSR or CSR. It doesn't really matter. What happens to the right side of the edge layer doesn't matter for the edge. If it's a CSR and this is only the outcome of the CSR, or if this is the SSR, we don't really care. We just cache, and maybe this is a better example. We cache whatever comes from these. If this is CSR, that's fine. If this is SSR, that's fine. And then the HTML content is cached. And when the user opens it, it opens either CSR generated HTML or SSR generated HTML. And of course, the hydration part needs to be there anyways. So with SSR, the hydration part happens, of course, on the client side in our browser. And how does it integrate? Well, it doesn't directly, but it works together quite well. Yeah.
Okay, so the last question, how do you avoid caching personalized or authenticated content by mistake?
Usually, since every single project is a bit different, I would say that it's a bit of a trial and error. And what we do in CloudSight, we really take care or like spend time on testing, because there are mistakes, of course, but we catch them during the testing phase. And when it comes to authenticated content, so for example, once you log in, you can see my account. So what we do is we understand how the backend works, how the API looks like. So we don't cache specific API requests which relate to the authenticated user. So that's one. And other than that, we don't we skip some of the pages, like checkout, like cart. So we have two types of caching in this case. We have API and we have HTML, and we skip some parts of the APIs which are authenticated, for example, in this case, in case of a question. But also when it comes to the HTML, we simply don't cache those. And yeah, ultimately, I would say that the most important part in the projects, performance-related projects I've been involved in, were the first meetings with the client, where we really talked through every single possible page, every single possible scenario where something should be cached or something should not be cached. So, yeah.
Okay, perfect. So no more further questions. So that brings us to the end of today's session. Thank you all so much for joining. Big thank you, Kacper, for sharing your expertise and giving us a closer look at how to boost Lighthouse score with Spartacus and the power of edge caching. We hope that you find this session insightful and that you are leaving with the practical takeaways. A quick reminder that the recording will be sent to you shortly, as well as additional materials about Spartacus on Edge. And of course, if you are interested in exploring the topic further, feel free to reach out to us. We would love to continue the conversation. And yeah, thank you so much for joining. Have a great day, and yeah, see you next time.
Thank you, guys.